Hello from Pymedix. We build fully automatic AI systems with machine perception technologies. Today we'd like to talk about what happens inside Autofuse, our advanced, fully automated, deformable image registration software. Autofuse uses machine perception technology, backed up by decades of neuroscience research, to emulate the brain's visual processing pathway, producing truly automated, advanced deformable registration. Let's see what this looks like in an example case. We start by loading a primary and secondary scan that we want registered. That's it. Autofuse does the rest. First, it gets to work detecting thousands of features in each scan. After finding all the features, Autofuse then describes each one. The description process is depicted here in yellow and is complete when the dots turn blue. We then conduct an efficient global feature match. Note that even though most of the matches look correct or plausible, there are some that aren't. So how does Autofuse decide which matches are real? By doing checks on each matched pair to make sure it makes sense. Like, does a feature pair share the same neighborhood? Are there enough neighbors? Would it cause excessive stretching? Once we've narrowed down the matches, Autofuse then goes ahead and deforms the image. No rigid registration required. At this point, Autofuse can gauge its level of confidence in the registration. In this case, it is 95% certain that the maximum average error lies within 8 mm. The actual average error is, of course, much lower. Autofuse then proceeds to fine-tune the registration, and the lines connecting matches are, as expected, much shorter. Autofuse again checks its matches, and the final result is ready. Autofuse's extraordinary robustness allows for some new and novel things, like in this study done by Cincinnati Children's Hospital, where Autofuse technology was used to measure how radiation treatment to the spine affects vertebral body growth, using scans taken 1 to 3 years apart in children who are actively growing at rates upwards of 50 mm per year. In the case shown, scans were taken about 31 months apart, at different resolutions, with the latter scan done with contrast. After loading the scans, we automatically get to work. We've accelerated the process here a bit for brevity. Autofuse produces precise, accurate, and detailed deformation maps, or in this case, growth maps, that clearly show reduced vertebral body growth in areas that received high doses of radiation. Thanks for watching. We hope we've made how machine perception in Autofuse works a little bit more understandable. Let us know what you think in the comments below, or for more information about Pymedix and Autofuse, visit us at pymedix.com or on social media.